top of page 3 in the section 3.1 notes, remember what I told you a few minutes ago. The simple interest concept is mostly going to be used with simple interest loans, but you can occasionally see a problem with a simple interest savings account or other simple interest investment. So if you look at the first bullet, it says the formulas for simple interest can also be applied to a simple interest savings account or other simple interest investment, with A being the final balance, P being the original deposit, I being the amount of interest accrued, R being the simple annual interest rate in decimal form, and T being the number of years the money is invested. Okay, so again, these simple interest formulas work whether you're looking at a simple interest loan or if you're looking at a simple interest investment. Okay, a couple of other words you may hear are present value and future value. So let's take a look at the second bullet point. The principal P. So remember, P is the amount, if you're looking at it from a loan perspective, P is the amount of money you've borrowed. If you're looking at it in terms of a savings account, P is the amount of your original deposit. So that principal is called the present value of your simple interest loan or investment, whereas A is the future value of the loan or the investment. Okay, so you can think of A, if you're thinking of a loan, you can think of it as the total amount of money you pay back. If you're looking at it in terms of a savings account, it is your account balance. Okay, so if we think of this in terms of loans, okay, P is the amount of money that I borrow. So if I went out right now and I made a loan of P dollars, presently that's the amount of the loan. Okay, as time passes, the amount that I borrow, I have to pay interest on it. So when it comes time in the future to pay the loan back, then I'm going to owe $8 total principal plus interest. And so that's why it's called the future value of the loan, because that's how much I will owe in the future. If you're looking at it from a savings account perspective, if I went right now and opened a savings account at the bank, P is the amount of money I'm going to put in the bank. That's how much my account balance is presently. And then over time, my money will grow through interest. So if I come back later in the future and check my account balance, A is going to be the future value, how much I have in the future. Okay. Last thing I want to say, and this is going to go for all the formulas in this chapter. Okay. You're going to get these formulas and you're going to have to solve for one of the variables. And you can solve for any one of the variables as long as you know the values of all the other values, or sorry, all the other okay, let me start over. You can solve for any one of the variables as long as you know the values of all the other variables in the formula. Okay, so we are going to start doing examples with the simple interest formulas. Okay, here are the directions you're going to see in this section. In all problems involving days, a 360-day year is assumed. Okay, for our purposes with this class, usually if you're doing simple interest, you're in days, you're going to use a 360-day a year. And if you're working in the other section, so with compound interest or annuities or amortization, you're going to assume a 365-day year. But again, do not worry. You will be told how many days to assume in the year. Okay. Keep going with the directions. When annual rates are requested as an answer, express the rate as a percentage correct to 3 decimal places unless directed otherwise. So that statement is just saying if you are solving for an interest rate, if your answer is going to be an interest rate, you need to express that answer as a percentage with 3 decimal places after the decimal point. Okay. Again, all of these problems involve money. So your answer is most of the time going to be a money amount. So your answers need to be rounded or stated as dollar amounts rounded to the nearest cent. Okay. All right. So always think dollars and cents. Okay. So in this first set of problems, so examples 4 and 5, okay, we're told to use the formula I equals PRT. okay? So let me just make a statement before we do these simple interest problems. I told you that when you take a test on this material, you're going to have a bunch of word problems all mixed up. You've got to figure out what situation is which. So how do you know that the problem you're looking at is going to involve simple interest? Okay, well, there's two ways you're going to know. Okay, I'm going to write them up here. Okay, so to recognize simple interest, okay, actually, let me put the word recognize here. So to recognize a problem as a simple interest problem, either, okay, the most obvious way is if it actually says simple interest in the problem. Okay, so problem will say simple interest. Okay, but sometimes that does not happen. You may not see that phrase, so you're going to have to use the alternate way of recognizing the problem as a simple interest problem, and that is the problem will not contain the word compounded. So problem will not contain the word compounded. Okay, that word compounded, it appears in every other type of financial problem, whether it's compound interest, or if it's an annuity, or if it's amortization. Every other problem in financial math, you're going to see this word compounded. Okay, so as long as you don't see that word in your problem, it is a simple interest problem. Okay, so in examples 4 and 5, I am telling you to use the formula I equals PRT. We will talk about why after we read the problem, why this is the formula of choice. Okay. And then I think in examples 6 and 7, we're going to use the other formula. So A equals P times 1 plus RT. Okay. And then in the remaining problems in this section, you're going to have to choose which formula, either the I equals PRT or the A equals P times 1 plus RT. You're going to have to figure out which simple interest formula is more applicable to the problem at hand. Okay, so let's concentrate on examples 4 and 5 where we're using I equals PRT. So in example 4, if $5,000 is loaned for 9 months at 6.2% annual, at a 6.2% annual rate, how much interest is earned? Okay, first thing I want you to think about is why this is a simple interest problem. Okay, if you read through this, and I'll read it one more time, if $5,000 is loaned for 9 months at a 6.2% annual rate, how much interest is earned? Okay, it does not specifically state the phrase simple interest, but you also do not see the word compounded. Okay, so that makes this a simple interest problem. So when you have a simple interest problem, you have two choices of formulas, I equals PRT or A equals P times 1 plus RT, okay? A lot of the times you could use either simple interest formula and get to where you need to be, but usually there is one formula that's easier to use over the other one, okay? And when you read this one, okay, the question is how much interest is earned, okay? So you're looking for interest. So you should be using the I equals PRT formula because this formula directly says you're looking at interest, okay? So we're going to use I equals PRT here, okay? So over here, I'm going to track the values of the variables. You should always read the question, okay? Usually the end of the question is going to tell you what you're looking for, how much interest is earned. So that tells you you are looking for I, okay? So that means you should know the values of all the other variables in the formula in order to solve for I. Okay, so let's go ahead and list those out. All right, this is a loan, okay? So P is the principal, how much money you are borrowing. We are borrowing $5,000, okay? The interest rate is 6.2%, but you've got to convert that to a decimal. So you're going to drop the percent sign and move the decimal point 2 places to the left. So that's going to give us 0.062. Okay. And then time has to be measured in years. Okay. Like I told you before, simple interest usually involves very short periods of time. So we are going to take this 9 months because that's the amount of money, that's the amount of time you borrow the money for, and we have to convert it to years. So to do that, it's going to be 9 months out of 12. Okay. You could reduce that fraction, but it is unnecessary to do so because plugging all this stuff into the formula and plugging into the calculator, it will automatically take care of that for you. So why go an extra step? Okay, so we're going to go ahead and plug all of this in. So we're going to do 5,000 times 0.062 times 9 out of 12. Okay, so all you've got to do is plug this stuff into the calculator and then round to the nearest cent. Okay, every time we do a problem in this entire chapter, I will be working it out on the calculator for you. Just, you should practice along with me to make sure that you can plug it into your calculator correctly, okay? If you have an older calculator, you may have to pay more attention to order of operations and be very cognizant about where you're putting parentheses and where you're not. If you have a newer calculator, usually it's going to display it really nicely and you can kind of easily tell if it's the same thing you have on your paper. If you're trying to do this, you know, with a cell phone or you're trying to do this with some very basic calculator, you're going to have trouble, especially when the formulas get more complicated. They are just harder to keep the order of operations straight. So it really is helpful to have some sort of graphing calculator to do this, just because they are structured to handle more complicated things. Okay, so for this one, literally, I just plug it in just like I see it. So I'm going to do 5,000 times 0.062 times 9 divided by 12. Okay, that's going to give me the answer. Okay, notice I didn't do any rounding of any number until the end, and this is actually a nice even decimal, so I do not need to round at all. So this is going to be $232.50. Remember, interest is money. It's dollars and cents. Okay, so the answer here is $232.50. Okay, when you're doing these types of problems, one of the good things is that you can kind of gauge whether or not your answer is right. Like, does it make sense? You know, you borrowed $5,000 in this problem, so the interest, this makes sense as in terms of the amount of money that, or the amount of interest that is earned on this loan. Like if you know, did some kind of calculation and you got a number way big, like something like $3,000, you know, that's not going to make sense. Would you pay $3,000 in interest on a $5,000 loan? Or if you got something more than $5,000, that's totally not right. So you can do little things to kind of say, you know, is this answer reasonable or not? Okay, so that's how you do the first problem. All right, in example 5, okay, again, you're told to use I equals PRT, okay? Find the term of a loan of $225 at 7% if the simple interest is $94.50, okay? This problem, point blank, tells you simple interest, okay? So you know this is going to be a simple interest problem. So again, you would have to decide between I equals PRT and A equals P times 1 plus RT. So when you look at this one, you've got to first figure out what are you solving for, what are you given, and then you can make that decision. So when you read the problem here, it says find the term of the loan. Term means time. So you are looking for time in this case, okay? Both formulas have time in them, so you're going to have to look at some other information that you've been given, okay? You are told that the interest is $94.50. $94.50. So you're given information about the interest. The interest is $94.50. So your best bet would be, this is why we're using I equals PRT, because we're given information about the interest, okay? All right, so again, we're looking for time. We know the interest. If we're solving for time, we should know the value of all the other variables involved. So let's write down P and R. Okay, so P is the principal, how much money I borrowed initially, so that's going to be $225. And then the rate, the interest rate is 7%, so you need to drop the percent sign and move the decimal point 2 places to the left, so that's going to be 0.07. Okay, plug all this stuff in and let's solve for time. Okay, so we're going to get $94.50 is equal to $225 times 0.07 times t. Okay. All right, so let's go ahead and solve for t. That means you have to isolate t on one side. Okay. We can go ahead and multiply the 225 times 0.07 and see what happens. We get a nice number, so we can go ahead and do that. Remember, if you had gotten something longer that did not terminate or didn't repeat, you are going to have to carry all the digits. Okay, but this next step, we can write down 9450 is equal to 1575 times t. And then if you want t, just divide both sides by 15.75. Okay, so then these guys will cancel. Okay, so t is going to be, all you have to do is $94.50 divided by 15.75. So let me do that here. Try to make sure you can see it. Okay, so 94.50 divided by 15.75. Okay, there you go. Okay, you get a nice even number. Okay, so t means t equals 6. Okay, so units are going to be extremely important when you do stuff like this. Okay, you know, is this $6? Or, I mean, what is this? Okay, remember, you are finding time. Okay, when you work with time in the formulas, time has to be measured in years. So when you're solving for time, the answer that gets spit out is also in years. So the answer here is 6 years. That's the term of the loan.